Yes, good evening all.
Sir.
How are you children?
Good, sir.
How are you all?
I'm good, sir.
Who is, I think new student has joined. Who is that?
Srinivas, I think, sir.
Yes. Hi Neha. Who is Neha? Neha Srinivas.
Good evening, sir.
Hi Srinivas. How are you?
Fine, sir.
Yeah.
How are you, sir?
Yes, I'm doing good, beta. See, can you please introduce yourself? I think this is the first class you are attending, right? Am I correct?
No, sir. Attended first Friday, I think, sir.
Achha, you attended the last class as well.
Yes, sir.
Okay, great. What about Neha? I think Neha also attended the last class.
Yes, sir.
Yeah. Then why didn't you attend the yesterday's class?
Sir, I had pre-finals, sir. So, they are alternate days, so I'll be attending a class one day and the other day I won't.
Okay, okay. So you have free final exams.
Yes, sir.
Okay, okay. So we were discussing what? We were discussing determinants, correct? Isn't it, guys? One second, I think it is showing some different. Yeah, we were going with the determinants. So today we'll be discussing the questions based on properties. How many properties we did yesterday? How many properties we did yesterday in yesterday's class? So I'll go with all properties one more time. I'll teach you all the properties today. Okay, people. So just a minute. Can you hear me, children? Am I audible to you all? Hello? Am I audible to you all? Hello?
Your voice is breaking.
Okay, just a minute. Now, can you hear me?
Yes, sir.
Just a minute. I lost the power. I have to connect it again. One second. Yes. So what I was telling is we discussed the properties. In yesterday's class, we discussed properties of determinants. Isn't it? Properties of determinants we did in the last class. So now we will, I'll just teach you now. I'll just remind one more time and revise one more time that properties. Then we'll go for the questions. Okay, I think where is that pen? Okay. Hope I can hear. Hope you can hear my voice clearly. Yes. So can you please, can anyone of you tell me what are the properties we learned in last class? What are the properties we learned? properties of determinants. Properties of determinants. Guys, am I recording? Check once. Yeah, it is recording. So can anyone of you tell me the properties of determinants? Make it fast. For the first property, I told you is the value of determinants remains unchanged even if you change the rows and columns. Value of determinant unchanged if its rows, I'm writing roughly guys, columns interchanged, columns and rows are interchanged. Correct? Yes. Now, one second. This is the first property we learned. What is the second property we learned? I think someone is in the waiting room. What is the second property we learned? Yes. Second property we learned, beta, here look at this. The second property which we learned here is, my goodness, why I'm not able to write? Can you see what I'm writing here? Yes. If any two rows or columns of a determinant are interchanged, then sign of determinant changes. Clear? So if any two rows or two columns of a determinant interchanges, then sign of determinant would be changing. Okay, next, third property. Are you able to understand what I'm writing there, beta? If you change any two rows or two columns in a determinant, then what happens? The sign of the determinant will be changing. Very simple. Next, third property, if any two rows, columns of a determinant are identical, then identical means corresponding elements. Their corresponding elements are identical in two rows or two columns, then determinant value would be 0. You can take example and check, beta, if you don't understand. Very simple. Next, property number 4 is what? If each element of a row or column of a determinant is multiplied by a constant, then the value gets multiplied by k. The value gets multiplied by k. So children, are you able to understand what my handwriting here? Neha, Srinivas, are you guys able to understand or not? So by fourth property, look at this here. By using fourth property, what we can do here is, look at this. First, suppose what I'm telling here, if each element of any row or column of a determinant is multiplied by a constant, then the value gets multiplied by k. So if I say, look at this, any element you say, a1, b1, c1, okay, a2, b2, c2, a3, b3, c3. So any element of row or column of a determinant multiplied by a constant, then value gets multiplied by k. So for suppose, look at this here, I'm multiplying row 1 with k. So ka1, kb1, kc1. So next a2, a3, b2, b3, c2, c3. So what happens now? I can take this k outside. A1, b1, c1, a2, b2, c2, a3, b3, c3. You can write like this. You can take that k outside as a common factor, and this determinant value would be multiplying by this k. That is what the meaning of the fourth property. That is what the meaning of the fourth property. Okay. Now here, guys, look at this here. If at all I have something like this, I'll give one more example so that you will understand it in a better way. So let me write 2, 4, 6, 3, 4, 5, and here you write it as 4, 8, 12. Okay. So now here, if you observe properly, 4, 6, so 2, 4, 6, 3, 4, 5, and here I can take 2 common in the third row. In R3, guys, I can take 2 common. Check. If I take 2 common, what happens? 2 2s are 2 4s are 2 6s are. Now, if I take 2 common from the third row, if I take 2 common from the third row, 2 4 6. Now after taking 2 common, beta, now row 1 and row 3 are identical to each other. They are identical to each other or not? So 2 into, if 2 rows or 2 columns are identical to each other, then determinant always will be 0. So 2 into 0 is what? 0. Okay, this is the one thing we have observed here. And one more thing is what? Here, if you observe row 1 and row 3, beta, they are proportional to each other. Here, row 1 and row 3 are proportional to each other. Proportional to each other. Proportional is nothing but having same ratio, isn't it? If they are proportional to each other, definitely I can take 2 outside, then determinant remains 0. Correct? Understood my point? Guys, if 2 rows or 2 columns are identical to each other, determinant will be 0. If 2 rows or 2 columns are identical to each other, determinant is 0. If 2 rows or 2 columns are proportional to each other, also determinant is 0. Very simple. I repeat again. For suppose, look at this. 1 2 1 1 1 0 2 3 1 1 1. So let's say that this is a determinant of A. What is the determinant of A now? Tell me. What is the determinant of A here? But here R1 and R3 are what? Identical to each other. Identical to each other. Then determinant is what? Of course, 0. Any doubts? But 2 rows are identical to each other. Determinant is 0. Directly, blindly, you can say determinant is 0. And let's say that you have something like this. So 2, 4, 5, and here you have 6, 7, 8, and you have something like this: 2 into 2, 2 into 4, 2 into 5. So you have, look at this here. R1 and R3 are proportional to each other, having same ratio. R1 and R3 are proportional to each other, then also determinant is 0. When 2 rows or 2 columns are identical, determinant is 0. Or 2 rows or 2 columns are proportional to each other, also determinant is 0. Hope it is clear. Next, property number 5. Property number 5. What property number 5 says here is, if at all I have a determinant something like, if some or all the elements of a row or column of a determinant are expressed. Let me write here A1 plus B1, A2 plus B2, A3 plus B3. Now here you say, you write something different here. Let us write something like this. K, K, K. Now here A2, B2, A3. Oh my goodness. Or else you write anything, no problem. A1, B1, C1, A2, B2. A2 already we wrote, right? So B1, C1. So here B2, C2, B3, C3. So let's say that you have a determinant something like this. You have a determinant something like this. How this determinant is looking like? This determinant is looking like sum of two elements in a row 1. In a row 1, we have two elements. We have their sum in the row 1. So this determinant still can be written as like this: A1, B1, C1, A2, B2, C2, A3, B3, C3, plus this can be written as K, 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 B1, B2, B3, C1, C2, C3. This can be expressed as in two determinants like this. If at all you have something like this can be expressed as this plus this determinant. That is property number 5 says to you. Hope it is clear. Property number 6 says that if I say any determinant, let's say the determinant of any matrix, let me say you have A1 here, A2, A3, B1, B2, B3, C1, C2, C3. You have something like this. And I'm writing one more determinant, let's say delta 1. So if I add and multiply with any row, look at this, what I'm doing here, beta. A1 I'm adding with K times of C1. What I'm doing here, beta, look at this here. I'm R1 changing as R1 plus K times of R3. If you do like this or anything you can do, C1 changes as C1 plus K times of C3. Anything you can do row wise or column wise. Then what happens? Let me tell you. Let me show it to and tell you. So A2 plus K times of C2. A3 plus K times of C3. So B1, C1, B2, C2, B3, C3. So here A1, this can be written as how now? A1, B1, C1, A2, B2, C2, A3, B3, C3, plus K times of C1, K times of C2, K times of C3, B1, C1. As it is, row 2 and row 3 will be same. Row 2 and row 3 will be same. B2, C2, B3, C3. Now look at this. If you observe properly here, R1 and R3 are proportional to each other or not? Proportional to each other. If two rows are proportional to each other, what happens? Their determinant would be 0. All right, isn't it? So this delta 1 is equal to, what is this as? Delta plus 0. This is delta beta. This is plus 0 here. So delta plus 0 is delta only. Delta 1 is equal to delta now. So what I'm trying to say here is, if you perform something like this, R1 changes as R1 plus K times of R3. C1 changes as C1 plus K times of C3. Anything, either row wise or column wise. Look at this here. R1 adding with what? Multiple, equi-multiple of R3. R1 plus K times of R3. R1 plus again K times of R3. Check. That is what I did here. R1 plus K times of R3 beta. So A1 plus K times of C1. A2 plus K times of C2. A3 plus K times of C3. In that case, I can just split into two determinants. And if I take a determinant, the determinant is also going to be remain same. So what is property number 6 says here? If each element of any row or column of a determinant, the equi-multiples of corresponding elements, look at this here. equimultiples k, k, k of corresponding elements, corresponding elements of other row. What I'm doing here, row 1 multiplying and adding with corresponding element of other row, which is R3. So what's happening here? Then the value of the determinant is remain going to be same, which means the value of the determinant remains same if we apply this type of property. Which type of property? Look at this. If you the value of the determinant is remain going to same if you apply this type of property. Sir, why you are applying on row 1 only? Why can't you apply on row 2, row 3, row 4? You can do like this also. Row 2 plus k times of R1. R3 can be changed as R3 plus k times of R2. Anything you can do. The value of the determinant is remain going to be same. Even you apply this. Okay. So all these properties we'll be using for solving the questions. So that is what I just wrote here. Look at this. I took this as one determinant, and delta 1, what I took here, delta 1 as another determinant. I'm adding after multiplying with equimultiples. Look at this, kc1, kc2, kc3. After doing this operation, look at this, boys. After doing this operation, I got this determinant. If I simplify this determinant as like this, I got this as 0 and this as determinant, which I took as. Okay, so both the determinants are same if you perform as per the sixth property. Okay, if you perform as per the sixth property, determinants are not going to change. So these are the simple questions. These are the simple properties, guys. I'll teach you an example now. You will understand it in a much better way. We'll solve the questions based upon this. Let's get into the questions, guys. I mean, based upon the sixth property only, I'll give a question. Based upon sixth property, I'll give you a question. So look at this here. A, 2A, 3A, A plus B, 3A plus 2B, 6A plus 2B, sorry, 6A plus 3B here. And column 3 given as A plus B plus C, 4A plus 3B plus 2C, 10A plus 6B plus 3C. You have to prove this as A cube. Prove that this determinant is equal to A cube. How can you prove that? By using sixth property, you can prove. Applying the operations. How can you prove it? Here, see here, you make sure that, look at this, we need to prove this as A cube. I have 2A here, I have A here. Okay, I have A here, I have 2A here. So how can I make this 2A and subtract it so that this place becomes 0? That makes my calculation easy. So I'm changing R2 now. R2 changes as what? R2 minus 2 times of R1. What happens now if I change R2? And R3 you change, and R3 you can change it as R3 changes as R3 minus 3 times of R1. So what happens now? R1 is going to remain same. A plus B plus C. R2 changing as what? R2 minus 2 times of R1. So 2A minus 2 into A, 0. So 0 here. So 3A plus 2B minus A minus B. So 2A minus B. So 2A minus B I got. Correct? So 2 times of beta, 2 times of. So you have to be very careful here. So 2 times of. So 3 R2 is what? 3A plus 2B minus 2 times of R1. A plus B. So 3A plus 2B minus 2A minus 2B. So 1A I got. So here it will be 1A. So here what you get here? So 2 times, right? So 2 times of A and 1 time of B, and that's it. After applying that particular operation, this is what I left with in R2. R3 is going to be what? R3 minus 3 times of R1. So here 0. So here 3A and here 7A plus 3B. This is what I left. Guys, after applying this operation and this operation, this is what the determinant I left with. Is it clear, guys? Are you able to understand? Are you able to follow? Guys, we have to solve as many questions as possible. Do respond whether you guys are understanding or not. Sir, why did you make them as 0? If I make them as 0, what happens now? Check. My calculation becomes very easy so that I can prove it very easily. So better look at this here. Now R3 let's change. R3 changes as what? I have 3A here. I have 1A here. How can I make this position as 0? R3 minus 2, so 3 times of R2. So R3 changing, right? So R1 plus R2 will be same. R1 and R2 will be remain same. So R2 is what? 0, A, 2A plus B. R3 is what now? 0 minus 0. 3A minus 3A, 0. 7A minus 2A, how much? 5A. And 2B. 5A plus 2B. Correct? Sorry, not 5A. 3 times of R2, beta. 3 times of R2 is 6. So you left with only A, 1A. That's it. You left with only 1A. Now find out the determinant of this particular thing. Beta, one more note here. You find the determinant always. You expand the determinant always wherever the maximum number of zeros you have. What you do here is you have to expand along with that particular row or particular column where you have maximum number of zeros. Now, where you have maximum number of zeros? In R3, you have maximum number of zeros. Correct? So I'm expanding along with R3 now. Expanding along with R3. So 0 into something 0 only, plus 0 into something 0 only. Next, here A into what? Closing this. What you left with now? A into A square minus 0 into something 0. So check 0 plus A square into A is what? A cube. So A cube is the answer. Check. How simple it is. Guys, did you understand how I did this? People understood? Neha, you understood? Neha? Now I would like to ask a question, beta, whether you guys are from like which board you are studying in. One by one, tell me. I'll tell you one by one. Wait 1 second, so that I can teach accordingly. Anjali CS CBSE, Dhairya I think state board, Jafar state board, Neha. What about you, Neha?
State board, sir.
You are. I think you have. I'm sure you might have done in class 11 determinants. Am I correct?
Yes, sir.
Then you are aware of this, but CBSE students they haven't done. So no problem. I'm going with the questions now. You have to follow this. Okay. What about Prashant? I think state board. What about Tanishq?
State board, sir.
State board. So only Anjali is from CBSE. Am I correct? Jafar. What
Yes,
about
sir.
Jafar ji.
Sir, state.
Okay. No problem. You can respond in the class. You can talk in the class. No one is gonna say anything to you. Mama Jafar. No problem. You can talk in the class. You can respond in the class. कोई problem नहीं है respond करने में. ठीक है? Please, when I ask you the questions, when I ask you something, please respond किया करो तभी तभी. Please don't keep quiet. Please do respond in the class. I'm not mad here to just keep asking again and again. Please try to understand this. When I ask something, say yes or no. That's it. That makes like, yeah, okay, this boy is from that, this. I can get a clarity. If you're not responding, it doesn't make a sense at all, please. If at all you have any doubts, feel free to ask the doubt, but don't sit with the doubts. If you have any doubts, sir, I didn't understand that. Please, could you come back again through that so that I can teach you again till you understand. I can explain you that. At last, I'll definitely make sure that you are understanding that. But if you are sitting simply without asking the doubts, without understanding, you can't survive in class 12th. I'm telling you, without understanding, you can't survive in JEE exam. Whatever the exam you write, not only JEE, you know where you can survive if you're not understanding. Try to ask if you do not understand. Don't feel shy. If you are feeling shy, text me personally. That makes a sense. That would be a good thing if you do so. If you are sitting simply, nothing comes to you. Understand, you are putting efforts. There is no point of, if you are not listening to the class, if you are not asking the doubts, which means you are not studying it. Look at this here. If you're not asking the doubts is nothing but, look at this. If you're not asking the doubts is nothing but, there would be two parameters. Either you might have understood everything, or you are feeling shy to ask. These are the only two things behind not asking the doubts in the class. What are they? Whether you have understood everything, whether you have not understood. You have not understood, but you are feeling shy to ask the doubts. Which is correct? Which is correct here? Feeling shy to ask the doubts, or you understood everything? I need an answer. Hello, people. Understood why we are doing all this?
Yes, sir.
Okay. Now look at this here. I'll give one more question. See, some determinant given to you like this. Z plus X, Z, X, Y, 1, 1, 1. You have to prove this as 0. Prove that this is equal to 0. How can you prove this as 0? How can you prove this as 0? See, beta, here. How can you prove this as 0? I can prove it very easily. Look at this here. You have X plus Y here. And one thing is missing. Which is missing here? Z element is missing. Here you have Y plus Z. One element is missing here. Which is that? X is missing here. Here one element is missing. Which is that? Y is missing. So what I have to do now? I'll be adding. How I'm changing? R1 I'm changing as R1 plus R2. If I do that, so beta, what happens now? Check. R1 plus R2. What is R2? Z. So I'll be adding here. Now what is R1 here? Y plus Z plus R2. What is R2? X. R1 Z plus X plus Y. Okay. So remaining things, remaining people will be as it is. 1, 1, 1. Correct? Now, if you observe this properly, here R1 and R3 are proportional to each other or not? They are having same ratio or not? Look at it, X plus Y plus Z, X plus Y plus Z, X plus Y plus Z. They are in the same ratio. So I can take X plus Y plus Z outside. If I take common 1, here also X plus Y plus Z common 1, X plus Y plus Z common 1. So now look at this, Z1, X1, Y1. Correct? So if I take X plus Y plus Z outside, so 1 Z, 1, 1, X, 1, 1, Y1. Now look at this, R1 and R3 are identical. If two rows or two columns are identical, the determinant would be 0. So 0 into something is always 0. Hence proved. How simple it is? How simple it is? Tell me. Look at 0. Hence proved. Correct? If you do not know the property, please go and read the properties first of all. Okay? Understood, beta? Please do read the properties first of all. If you are not good at properties, try to read the properties and come here, so that you can understand in a well manner, and that too in a very quickest manner. Chalo, next. Next, guys, finding area of the triangle. Finding area of the triangle. What is the formula for finding area of the triangle? I think I have given the notes on that. Am I correct? Did I give any notes on finding area of the triangle? I mean, determinants. One second, let me check.
Sir, we did that in matrices, right?
No. In determinants only, beta. By using determinants, you can find out that. I'm asking whether I have given the notes or not. Did I give any note on the area of the triangle? Can you hear me? Okay, properties of determinants. I think I taught you the area of the triangles. I taught you area of the triangles, adjoint, everything we taught. Yes. Area of the triangles I have given to you. Please, those who are missing it, please go on that. Please go through the area of the triangles formula, which was area of the triangle formula is what? What was the area of the triangle formula? Very simple, beta. Area of the triangle can be found out by using this formula: half into x1, y1, 1, x2, y2, 1, x3, y3, 1. By using this formula, you can find out area of the triangle. This was a formula for area of the triangle. So what is x1, y1, x2, y2 here? x1, y1, x2, y2 are x3, y3, they are vertices of a triangle. x1, y1, x2, y2, x3, comma y3 are vertices of a triangle. Then you can find out area of the triangle like this. You take this as a note if you want. Okay, next concept, guys. Inverse, transpose of a determinant. Transpose of a determinant. So first, suppose any determinant if I take, let's say a1, b1, c1, a2, b2, c2, a3, b3, c3, something like this. Transpose, how can you do the transpose here? Very simple. You say any, I'm giving a determinant of a here. Determinant of a is simply denoting with delta. Delta represents determinant. So delta to the power of 3 is what now? Determinant transpose. So a1, a2, a3, b1, b2, b3, c1, c2, c3. Row becomes columns, column becomes rows. That's it. Okay. So see, this delta is going to be symmetric. If delta is equal delta to the power of 3, then symmetric. Symmetric. Then skew symmetric is what? Delta is equal to minus delta to the power of t. That's it. Or this is skew symmetric. What is that? Skew symmetric. All right. Very simple. So how to multiply two determinants? Multiplication of determinants. How to multiply two determinants? Guys, it is same as like as multiplication of 2 by 2 and 3 by 3 matrices. How? Same as multiplication. Clear? So yeah, this is what basically you must know. And guys, we'll just get into the questions now. I'll give the questions. Just a minute. And I'll tell you a shortcut. I'll teach you the shortcut how to find out E inverse. How to find out E inverse of a matrix. I'll tell you the shortcut. Just a minute. Yes. People, are you able to follow? I think state board students already know what is determinant, what is matrix, everything they know that. It is a kind of revision to you all people. Children, are you here? Are you guys able to understand or not? Tell me. Hello, guys.
Yes.
Are you people able to understand? Neha ji.
Yes, sir.
అర్థమవుతుందా?
Yes, sir.
Shortcut for finding A inverse. How to find out shortcut? I mean, how to find out A inverse by using shortcut. Let me take any matrix. Let's say that A matrix has 0, 1, 2, 1, 2, 3, 3, 1, 1. Guys, for finding this, A inverse, we have two different methods. What are they? One, by using elementary operation. By elementary operation. And the second one is what? By using the formula called A inverse is equal to 1 by magnitude of A into adjoint of A. Okay. But guys, by using these two things, I mean here adjoint A, how can you find out adjoint A? First, we have to find out minors. Then you find out cofactors. Then you find out adjoint. This process we have to do. Then you can find out by using the second formula. But I'll tell you the shortcut here. Very, very simple. By using this formula itself, you can apply the shortcut. Look at this. First, write first of all, you write the as it is matrix. As it is matrix, write it 0, 1, 2. Okay, 1, 2, 3, 3, 1, 1. Listen to me carefully. It is going to be very helpful to you. You wrote the as it is matrix, right? Here, this is my row 1. This is my row 2. This is my column 1. This is my column 2. Correct? So, but I'm repeating column 1 and column 2 again. What I'm doing here, I'm repeating column 1 and column 2. What is the repeating? What is the column 1 and column 2 here? Look at this. Repeating column 1 and column 1, 0, 1, 0, 1, 1, 2. Correct? 0, 1, 1, 2. Then 0, 1. Here, what I'm doing here, try to understand properly. Here, 3, 1 and 0, 1, 2, 0, 1, 1, 2, 3, 1, 2. I wrote like this. I'll tell you what I have done here. Very simple. Look at this. What is the matrix given to you? This is our matrix, correct? This is my given matrix. Now here, what I'm doing here, I'm repeating column 1 and column 2. Check this one and this one. Repeating column 1 and column 2. Repeating column 1 and column 2. Here what I'm doing, repeating row 1 and row 2. Repeating row 1 and row 2. Check. People are able to understand what I did here. Here, beta, I repeated column 1 and column 2. Look at this. Column 1 is this one. Or else, if you want me to write one more time, I'll write again and show it to you in a very simplest manner. But this is the given matrix to you, correct? This is the given matrix to you, right? I'm asking you to repeat column 1 and column 2 again. So what is column 1? Column 1 is what? 0, 1, 3. What is the column 2? 1, 2, 1. I repeated that. Good. Fine. Next, I'm asking you to repeat row 1 and row 2 now. What is the row 1? This is the row 1. This is the row 2. I repeat the same row again. 0, 1, 2, 0, 1. I repeated row 1 again. Repeat row 2 again. 1, 2, 3, 1, 2. I repeated row 2 as well. Repeated row 1 and row 2. This is the repeated row 1 and row 2. Now, what you have to do here is, I just made this matrix, given 3 by 3 matrix, I made as 5 by 5 matrix. Now strike out R1 and R1 and column 1. Striking out this one, striking out this one. So what you left with now? You left with 4 by 4 matrix, this one. Correct? Now you find out determinant here. Very simple. Here we are multiplying the elements column wise and writing the row wise. What we are doing? We are multiplying the row wise like this. Multiplying the elements column wise. 2 into 1, let me write here. Okay, multiplying the elements. 2 into 1, how much? 2. 2 minus 3, how much? Minus 1. Minus 1 I got here. Okay, next. 1 into 2, how much? 2. 2 minus 1 into 1. 2 minus 1, how much? 1. I'm writing 1 here. Correct. Next, 1 into 3, how much? 3. 3 minus 4, how much? Minus 1. Next, what I'm doing here, beta? Multiplying the elements column wise. Check. Multiplying the elements column wise, writing the elements row wise. Multiplying the elements column wise, writing the elements row wise. Now check, look at it here. This into this. 3 3s are 9. 9 minus 1, 8. Isn't it? Yes. 1 into 0, 0. 0 minus 6. Minus 6. 2 into 1, 2. 2 minus 0. 2. Next, 1 into 1. 1 minus 6. Minus 5. Correct? So 3 into 1, 3. 3 minus 0. 3 minus 0, 3. 3 minus 0, 3. 0 minus 1, minus 1. So what I'm doing here, multiplying column wise, writing row wise. Multiplying the elements column wise and writing row wise. So that's it. I got my A inverse answer. Look at this. What is A inverse answer now? What is the formula for A inverse? A inverse is equal 1 by modulus of A. This is basically adjoint of A, beta. This is whatever we wrote here. This is adjoint of A. Now for finding A inverse, what is the formula? 1 by determinant of A into adjoint of A. What is the determinant of A basically? You have to find out first of all determinant of A. What is determinant of A? Expand 0 into something 0 only. Minus 1. 1 minus 9. 1 minus 9. So minus 8. So plus 2 into 1 minus 6 minus 5. So how much? 9 minus 10. So minus 1 is your determinant, right? Minus 2 is your determinant. Determinant of A is what? Minus 2 I got. Okay, now look at this. Determinant of A I got minus 2. Just 1 by minus 2 into adjoint of A. What is adjoint of A? This matrix. Write it. 1 minus 1. Or else directly you write. Let me write directly, beta. Why? So determinant of A is minus 2. So minus 1 by 2. 1 by 2. So minus 1 by 2. Minus 2 we got, right? So minus into minus. So minus and minus will get cancelled. So 1 by 2 here. Minus 1 by 2 here. 1 by 2 here. 8 by minus 2. Minus 4 here. So 3 here. Minus 1 here. 5 by 2 here. Minus 3 by 2 here. 1 by 2 here. This is what A inverse. Any doubts? Any doubt, guys? I repeat once again. Look at this here. I repeat once again. Let's say you have 3 by 3 matrix. You have 3 by 3 matrix, beta. Okay. You have 3 by 3 matrix. So first of all, what you have to do here is you have to write the same as it is matrix. As it is matrix, you have to write. Check. Look at it. You have to write as it is matrix. I wrote as it is matrix here. This is the as it is matrix which I wrote. Let me use this. This is as it is matrix I wrote here. Now this is my column 1 and column 2. This is my column 1 and column 2. I repeated same here. Look at this. I repeated column 1 and column 2. Very good. Now how many rows it became now? 3 rows it became. 1, 2, 3. So these 3 rows became. I'm repeating row 1 and row 2 here. This is row 1, this is row 2. I'm repeating again. It became as 5 by 5 matrix now. So after that, what you have to do? You have to strike out row 1 and column 1. And you have to operate on 4 by 4 matrix now. So you have to multiply column wise, write the elements row wise. So 2 into 1, 2 minus 3 minus 1. 1 into 2, 2 minus 1, 1, like that. 1, 3 is 3, 3 minus 4 minus 1. Multiply the elements column wise, write the elements row wise. That is very important thing you have to remember. That is a shortcut. Multiplying column wise like this, writing row wise. Multiplying column wise, writing row wise. Multiplying column wise, writing row wise. Very, very important. Okay. So this is how you can just solve this inverse of a matrix by using shortcut. Okay guys, if you have any doubts, you can try any matrix by using this shortcut. You can try any matrix. You can find out very easily. Actually, you can find out very easily. All right, people. So this is how you can do this better. So we'll be meeting in the next class. Until then, goodbye. In the next class, I'll be coming with full JEE questions. Until then, goodbye. Thank you. Have a nice day.